Hey everyone, my name is Chiranjeevi and welcome to my design pattern video tutorial series part 6. And in this video we are going to discuss the builder pattern. So let's quickly get to the definition of what this builder pattern is and what is the problem this pattern is trying to solve. Here's our definition. It's a creational design pattern that lets you produce complex objects step by step with the same building process. Yeah, that's it. But to understand this builder pattern completely, you need to understand the underlying problem it's trying to solve. So we'll quickly take a look at the problem which this builder pattern is trying to solve and try to understand why should we use builder pattern and at what scenarios it is applicable. Right, so here's our coding example which will take a look at why builder pattern is important. So the first thing which comes to our mind when we are creating a complex object which has a lot of members and fields and nested objects. So the first thing which comes to our mind to create this kind of object is to have constructors which take a lot of parameters. So imagine a scenario where you are building a very complex object that requires so many fields to be initialized, and there are multiple instances of that object spread across your code base which can or possibly cannot have all those properties initialized at once. So basically you have a combination of those objects in which several properties are relevant at a specific point in time. So for the demonstration purpose here, I have this house object which I need to create, which have so many fields inside it. It has its area, it has number of doors, number of windows, number of rooms, wall color, floor type, the design of the floor, number of lights, doorbell sound. And also these are the primitive types which the house has. We have some nested objects also which are there with the house, which is like furniture and swimming pool. So it's clear like not every house you see has a swimming pool with it. So let's look at how we'll construct this object. So there are two ways you can construct this complex object. The first one is to have very large constructors. As you see here, this is a very large constructor which has so many arguments in the instantiation logic. And not every instantiation will use this all the uh, properties to set. So most of the properties will be unused if that is not required by a client code. The way we can solve this problem is by overriding the constructor with different number of parameters required for the instantiation. But we will see why this approach is bad. We still have a lot of parameters if the object is very complex to create. So this approach, having a very large constructor, is very bad because if you add one more argument to the constructor, you need to change all the areas where this constructor was being used, and you need to update the test cases, and you need to do a lot of things to make the code more stable. And clearly we see this is a code smell, which is not a good design practice to have in your code base. The other way around to solve this problem is to subclass the house object and create relevant subclasses which will extend the behavior as they want. But the problem with this approach is you will have a very large hierarchy of subclasses if the number of variations in the product itself is huge. So we should also not prefer going through the subclass approach and also this constructor initialization approach. So as you have seen the problem here, we'll quickly go and take a look at what the builder pattern is and how it tries to solve the problem. So we'll start by looking at the UML diagram. So here's our UML diagram of the builder pattern. So in this UML diagram, as you can see, we have a builder, which is an interface which provides specific methods to build all the different parts of the product we are trying to build. So In the definition, we saw that it's a creational design pattern that lets you produce complex objects step by step with the same building process. So, what this means is to build any product, you will provide an interface which will expose different methods to build the product in a step by step manner. So, what this builder interface will basically do is to provide all the different steps which we require to build the product. Also, all the concrete builder instances which will implement this builder will provide their own implementation of building that particular part for the product. And we'll have one more method which we will use to return the instance of the product which we created. We can also optionally have a director class which will have a reference to a builder which can be injected at runtime to get the product which we want to create. So the importance of having this director class is that you can actually control the order of steps which are being executed in the builder. So what you can possibly do is have separate methods or separate ways to use this builder to create different instances of the product object. If you're not using a director class, the way this builder is executing the steps depends on your choice, and you have to do a step-by-step initialization of every part of the product this builder is trying to build. So that's enough of this UML diagram. I hope you have understood what this means, and now we'll quickly go ahead and implement this in Java. Okay, so the product we are trying to build here is not our house. We will be trying to build a simple object which will demonstrate all the possible scenarios for the builder pattern. So here we are trying to build the product which is a robot, and we have a builder class for this robot which have a fixed number of instructions what we need to build a particular kind of robot. So this is our builder interface, which is represented by our robot builder, which have a set of steps which we'll need to build the robot. On the other hand, we have two concrete builders. So the first builder is a humanoid robot builder, which we will be implementing in this example. And the other concrete builder is the RC car bot builder, which also implements the robot builder interface. So let's have a look at the robot itself. So our little robot has a set of arms, legs, head, doors, wheels, sensors, and firearms. So these are the properties which our robot will have whenever it's created. So clearly you can see, since there are so many of them, our constructors will be very, very huge. So this sets a very good example for a builder pattern. We'll quickly generate the getters and setters for all these properties. We'll generate. We'll generate for all of them. Here we have the getters and setters. We'll now quickly go and implement our humanoid robot class. So we'll first start by defining all the methods. We'll use our IDE for providing a default implementation for the robot builder. So now we'll go to our humanoid robot and we'll provide the default implementation for all the steps we have defined in the robot builder interface. We'll also need an instance of robot in our humanoid robot builder class on which we will be building upon. Also, we'll need a constructor to instantiate this humanoid robot builder itself. So we'll quickly go and create one. Let's stick with the default constructor for now and also add a init method to the robot builder interface. So now we'll quickly add the behavior for each of the steps in the builders we already have. We'll quickly go and also implement the methods of this RC bot builder, and we will also add a robot to this. Let's also provide a default constructor for this RC car bot builder. So now we have everything in place. We will try to fill the steps in each robot builders and then see how this is helpful. So we'll first start with the humanoid robot builder. In the init method, let's quickly instantiate the robot. And let's add the behaviors for each of the steps defined in this class. So as you can see, we have provided all the definition of the steps we need to build this robot. We'll quickly go to our RC robot and provide the implementation for all these steps once more. So I have skipped the filling of all the step definition in the RC robot car. I have already filled it for you, and as you can see, we have all the steps defined in this RC bot builder. And in the build method, we are just returning the robot which we have built. So we'll quickly go to the main method and we'll see the builder pattern in action as we have implemented the robot itself, the builder, the humanoid robot builder, and the RC robot builder. So we'll quickly go to the main method and start building bots. So to instantiate a bot, we will need a robot bot builder. So let's quickly create a robot builder. Let's try to build our robot. Since we are not using the director class approach, we have the control to build the robot ourselves, and we'll try to assemble the robot with specific steps we have provided in the robot builder. So let's go ahead and first assemble let's init the bot. Then we will try to assemble the head, and then let's try and assemble the arms. Then try to assemble the legs, and then we will try to assemble the what else we need. We don't need firearms, we need head, arms, legs, we need sensors. And when you need the robot, we can actually create an instance of the robot and ask the builder to return the instance of the robot we have already built here. So if you run this code, we'll have a humanoid robot Sophia, which will have all the properties which we need or which we have instantiated in the humanoid robot builder. So let's quickly run our code and we'll try to look at the builder object and the robot object and try to see how the building process is being executed. So first, we don't have a builder object. We created the builder object. We'll go ahead and we are at the init bot phase. So if you take a look at the builder, the robot object is actually null. So after this step, we have a robot object initialized with all its properties as null. So we'll quickly go and execute the next step. So we see that our head is initialized and it has a nice property. We also see the message assembling head complete. We'll quickly go and assemble the arms. As you can see, our arms method set. We have also successfully set our arms. We'll go ahead and set the legs. So you can see we have the legs set and the sensors are also initialized properly. So at the end, we are asking the builder to build this object and return it back. So let's quickly have a look at the Sophia object which we just created using the builder pattern, and we see that all the properties are set that we wanted. So thank you guys for watching my video. I hope that you have understood the essence behind the builder pattern and the problem it is trying to solve. If you like this video, please comment and subscribe, and I'll see you in the next one with the singleton pattern. Bye bye.